castle where the digital dreams come alive. CESCG takes place from May 1 to 5, from visualization to the virtual space. Scientific sessions take their place.
Good evening, everyone. Thank you for listening to my talk, first off. My name is Ayla Abdukic, and I'm a student at the Sarajevo School of Science and Technology. My paper is called Comparing Interaction Methods in a VR Rock Climbing Simulation. Rock climbing is a very hard, almost complex extreme sport that is very risky and requires a lot of strength, and not everyone can actually participate in that sport. So what we envisioned, my supervisor Boyan and I, to create an enhancing VR rock climbing simulation that focuses on interaction methods. That was our objective. There have been previous works that shed light into extreme sports VR simulations, and none of them actually focused on interaction methods. So that's what we tried to do with this paper. The methods we used were, first off, VR controllers, then hand tracking, and lastly, TactGloves. So for the VR controllers, they're basic. They offer precise control over the movements and interactions, but they lack realism, which hand tracking helps with. And hand tracking enables users to interact using their hands and the hand gestures, providing a more natural and intuitive interaction method. And lastly, TactGloves by bHaptics. They provide tactile feedback, which the hand tracking basically doesn't have. Also, what's great about TactGloves is that I got to experiment with them firsthand because they came out last year, approximately, and there has been only 2 papers that were referencing this product. And also, they're the first consumer-ready TactGloves that came out, haptic gloves. As for the case study and implementation process, so to make the simulation more realistic and immersive, we actually got inspired and filmed a 360 video, me and Boyan, at a location called Babin Zub. That's a rock formation near Sarajevo, if anyone's wondering. And we implemented the code and the 3D models in Unity. And for the 3D models, actually I 3D modeled almost all of them in Blender. As for the interaction part, the functionalities, I have written a couple of custom scripts in C# for the physics engine, and also minor details that are very important, like, for example, the restart button if a player gets stuck or doesn't want to continue. And using XR Interaction Toolkit, I have enabled locomotion and the interaction. Also, as I mentioned before, bHaptics came out with an SDK that provides the tactile feedback, so it activates the gloves. The gloves have 10 sensors in total, so 1 sensor per fingertip. I've used their scripts for receivers and senders, basically. So the hands, the controllers have the receiver script attached, and the climbable objects, you can see up the blue and the orange spheres have the sender scripts attached to them. So that's how they are activated by collision. As for the sphere objects, I've put some color indicators so the user can actually better distinguish when they're hovering over the interactable objects, when they're actually grabbing it. So when they're hovering over them, a blue color shows up, and when they are grabbing it currently, the orange color indicator activates. As for the implementation I mentioned before, we used Unity for the environment, the custom scripts, lighting, and the SDK. And for the modeling and texturing, everything was done in Blender. Regarding the user experience evaluation, so I'm not going to read all of this. The user, when they put on the headset, they were introduced to the Babin Zub location with a manual, basically, telling them how to interact. And in a total of 30 participants tested the interaction methods, first starting with the VR controllers. then hand tracking, and lastly, TactGloves. Through questionnaires assessing immersion, realism, ease of use, and physical comfort, participants provided us valuable feedback on their experience with each interaction method. The results were actually pretty surprising. So regarding the ease of use, for each interaction method, in the lead was actually hand tracking with 59.3%, then came the VR controllers, and lastly, haptic gloves. For the interaction method that they found more immersive compared to the other ones, in the lead was also hand tracking with 48.7%, then came in the VR controllers, and lastly, haptic gloves. But what was even more surprising was that 66.7% of testers actually perceived realism of haptic feedback better using TactGloves compared to VR controllers. I forgot to mention that also the VR controllers had haptic feedback, but it wasn't as strong as the TactGloves, so that might be the reason. As for my conclusion, general preferences for hand tracking in immersion and realism was shown, but there's always room for improvement. Also, what was the main reason why haptic gloves weren't at the top was actually a hardware limitation by the Meta Quest 3, because not only did I have the problem, but some official apps from bHaptics were also glitching while using the gloves. So every time a user moves their hands further away, the cameras either lose track of those gloves, or something else happens which we didn't discover yet, but we hope to do so to improve the VR app. So they would lose the connection and they would glitch or disappear, and after they reappear, the grab isn't working anymore, so they fall. That's one of the reasons why the gravity was disabled, just so we can figure out what's wrong with the gloves. Also improving precision and responsiveness, that's what I mentioned for intuitive interactions. So here is a short video. I think they played it at the fast forward, so it's just a visual representation of how every method works. This was tested on the first version of the app, so the textures were a bit iffy, but it's VR after all. So, thank you again for listening to my talk. And if you have any questions, please feel free to raise your hand.
Thank you, Ayla. Do we have questions? There are 3 questions. Okay, I will go first this one.
Did the user report that they were afraid of height?
Yes, we had that question, and we also warned them beforehand, so they are very aware of that, but they still try to fall for some reason. I think it's the junky adrenaline that they don't get to experience in real life, but they did.
I would like to ask you about latency, your system. There's some climbing for time. You need to climb very fast. And I have some experience with some activities.
Okay.
And this virtual set can track my fast moves. What about your system? If I try to climb very fast?
If you try to climb very fast, I actually tested that, so thank you for mentioning it. It doesn't glitch. It doesn't glitch with controllers because it's more, it tracks faster. And also it doesn't glitch with hand tracking. But with gloves, it's way slower. And if you try to move fast with your hands, it will automatically glitch. You will lose the hands, basically.
Mm-hmm. So it's not low latency?
It does. It does a little bit with the TactGloves while using TactGloves.
I have a question about one particular issue. When I'm climbing on a rock, I usually use both hands. So there is phase of a movement when I have one hand free because I'm moving it somewhere. But then when I'm moving the feet, of course, my hands are both together at the same place. On the rock, they are stable on the same place. They can't move. But having VR controllers or even not, even having hand tracking, my hands can still move freely, even if I maybe don't want it consciously, and go away. So the distance between the hands can differ. They can move even from the left-hand side to the right-hand side. How do you tackle this different situation in virtual space in comparison to the real space where the hands are really, they can't move because I would fall down?
So with using the TactGloves would be a bit tricky because of the basic problems, but using VR controllers and just hand tracking, I would probably, how I would solve that problem, I would create custom scripts and attach them to the controller's hands, like the mesh, and disable, like if they move, if the position changes, it's locked there in VR, but in reality it's different. So, but the problem with the gloves is if I can write the same code for that, it would probably work. But if I move my hand further away, it would still glitch. So it's more of a polishing addition to this project, but we really need to focus with the main basic problems to be able to solve that one currently.
At least for me, it was a basic problem, because then it turned out that people were able to cheat in this way, because when they changed the distance of the hands while holding on the rock, they were able to pull lower and then reach some grips that they wouldn't have been otherwise. So this was, at least in the simulation I did, this was kind of something we needed to take care of, but we were not able to 100% correctly solve it. Maybe another small issue, I noticed that the climber on the video is climbing with the hands like this.
Oh, with
which is usually...
you mean like pinching?
No,
or
like the distance is too small. Usually when you climb, you try to reach very high up, and then you hold the grip until it's in your pelvis area, and then you are reaching for the next one. But I fear with controllers there's no problem, but how is it with hand tracking? Would it still be able to track the hand over this large interval of height?
No, it would not, because I've tried that. It loses the connection, especially if it's like a smaller place. So it was a static boundary, and it does lose the But also in the video, I've used separate videos of the testers, and in the Unity part of the video, I was the one who was climbing it. And the other part is just one of the testers. So I kind of said that's why it doesn't match with the. But also, yes, they could cheat, but I didn't have such testers to experience that issue. So thank you for letting me know about that feedback. Thank you very much.
More questions? Do we have? No? Then thank you very much, everyone. This is the end of the session.
Swim to the beach where the pixels play. From rendering to VR, it's a pixel away.